One of the things in this section on making connections is looking at how confidence intervals are connected to hypothesis tests. So far, we've sort of explored them as two different concepts, but they actually are related in terms of the information they could tell you. And so if we think back to doing a confidence interval, let's say we get a confidence interval for P of like 0.28 to 0.53. We know that the values in this interval are likely, and so what that would tell us is like a value of 0.51 is a likely value. That means that if I was testing for a null of 0.51, because 0.51 is a possible value, when I did this test, I would not reject this null. However, let's say I was doing a test where I was looking at a value of 0.72. When I was doing that test, I would reject the null of 0.72 because it does not fall in the interval. So we can see if the null value falls outside the interval, then we would reject the null. If the null value falls inside the interval, then we are going to not reject the null. The two other pieces of information that are important here is that we are looking at a two-tailed test, and that is just to mimic the fact that when we do a confidence interval, we consider this two-sided because we have a lower bound and an upper bound. The other piece of information is if you read these statements, we're doing a 95% interval with this 5% significance level. And so these two numbers are complementary in that if we add up 95% plus the 5%, we get a total of 100%. So if we were doing instead something like a 99% interval, that would match up with alpha 0.01 so that they were complementary. And so that's listed down here in the bottom is that we have this relationship. So the next example we have is just looking at the connection between these things. And so these are already filled out, but we're just going to run through what we would say for these. So there is a poll conducted in August 2010 where we have a random sample of 1,013 American adults, and they were asked, do you approve or disapprove of the way Congress is handling their job? The proportion who said they approve was 0.19 from our sample, and we got a 95% confidence interval then from 0.166 to 0.214. And this is at a 5% significance level, so that is telling us that we're using alpha 0.05. So in A, we're testing to see if there's evidence that the approval rating is different from 25%. Okay, so think of that like P equal 0.25 and P differ from 0.25. Okay, so what we want to know is whether or not that would be a likely value and what our conclusion would be. 0.25 is not in this interval, and so we would reject a null of 0.25. So we would have a significant evidence of the alternative, which is that the proportion of approval differs from 0.25. Now we're testing to see if we're different than 20%, so that would just be 0.20 here. 0.20 is in the interval, and so we would fail to reject that null. And we would say we don't have significant evidence the proportion of approval differs from 0.2 or 20%. And then there's a 13%, so that would be here 0.13. And 0.13 is not in the interval, so we would reject a null of 0.13, and we would have evidence that the proportion of approval differs from 0.13. So we're just looking to see if the value is in the interval or not, and if it's in the interval, we do not reject that null. If it's not in the interval, we do reject that null. And then if we wanted to change to a 1% significance level or alpha 0.01, as I mentioned before, we would need to be looking at 99% confidence intervals instead because that confidence amount has to complement the value of alpha.